This question, the first thing that really stands out to you is that it's not y equals something. You have a y here and you have a y here. So when it's not y is equal to something, we are going to go through our implicit differentiation process. And when we talk about implicit differentiation, it is important to realize that you are differentiating with respect to x. So what I'm going to do is I'm going to start off by taking the derivative with respect to x of both sides. And because there's a mismatch with the y variable, I'll have to multiply by y prime. So when I take the derivative with respect to x, there will be this multiplying by y prime to complete the derivative, and that comes from the chain rule. Now, the other big thing to the other big thing to notice here is that this x is being multiplied by y. So we have a variable being multiplied by another variable. So anytime you have a variable times a variable, you need to go through the product rule. So for the product rule, my first function will be x and my second function will be y. The first function's derivative is just 1, and then the second function's derivative, if it was just x, it would be 1, but because it's y, we have to say it's 1 times y prime. So the derivative of y is y prime. Now, for the product rule, we do the cross, starting over here with the second, and then taking addition of this other diagonal. So plugging into the product rule here, I will have 1 times y, so just y, and then for this other diagonal, I will have x times y prime. Okay, so those first two terms are from the product rule. Now, we then add that to the derivative of our y squared, which would be 2y. But because there is this mismatch between the x variable we're differentiating with respect to and the variable, we have to multiply by y prime. And another way of just thinking about this is with implicit differentiation, you will be multiplying by y prime. And then we have the derivative of 10, which is just going to give us 0. Okay, so that's our first step, is we take our derivative. Now, once we take our derivative, then what we have to do is we have to get our y primes on one side and our no y primes on the other side. Okay, now for this particular question, there's not too much work there to do because there's only this term y that needs to move to the other side of the equal sign. So what we would do is we would subtract y from this side, subtract y from the other side, and then we would keep these y prime terms on the left-hand side. So we would have xy prime plus 2y y prime is equal to negative y. Now, once you get your y prime side, all of your y primes on one side, you're trying to isolate y prime, and usually the way you're going to do that is you're going to factor out a y prime. So if you factor out a y prime here, then you're going to be left with, as the other factor, x plus 2y is equal to negative y. And then you can divide both sides by x plus 2y, and then that multiplication is going to be undone by the division, and then divide over here by x plus 2y. Okay, so you get y prime is equal to, and please note you cannot cancel this y with this y because of that big addition sign, and addition is not going to be undone by division. So there truly is no other simplification that you can do here. You will get negative y over x plus 2y as your final answer for your derivative.